Our essential question for this lesson: what is domain, range, and a function, and what are the key steps to graphing a function? So let's start with some definitions. First, a function. So a function is a pairing of inputs with outputs such that each input is paired with exactly one output. So we are going to look at some examples of this, and the idea is that for each of your x values, there is only one possible y value associated with each of them. So we'll look at examples of what makes a function and then what kind of example would not be a function. Next is the domain, and that consists of all numbers called the inputs or the x values. So all your x values are your domain. So if I ask you to list the domain, you're just going to list all your x values. And the range, that contains numbers called outputs. So those are your y values. So if I ask you to identify the range, what is the range? You're going to list all your y values. You want to take note, this is not the same kind of range that we used when we did statistics. Okay, this is a different kind of range. This is a list of all the y values, so keep that in mind. So here's an example. This example, we have, and it's an input-output table. It shows the amount of money Miguel earns at his job for several numbers of hours. Identify the domain and range of the function. So here is an example where I'm asking you to identify the domain. So you write domain, and then you're going to list all the values in the domain. In this case, 2, 5, 7, and 8. So the domain is all the input values or x values. The range is a list of all the y values or output values. So the range in this case consists of 14, 35, 49, and 56. So those are the domain and range of this function. Example 2. So up at the top, you don't have to rewrite that. That's just a recall that a function is where each input is paired with exactly one output. So we're going to tell whether each of these pairings is a function, and we'll explain why or why not. So if you look at A, we have each of our x values. Okay, each number is different. The 2 only has one y value associated with it. 0 goes with the 2. 4, the number 4 only has one number associated with it. Okay, 3 is associated with 4. The 6, so we're looking at the 6. The 6 only has one number associated with it. Okay, the 3 is associated with the 6. 8, the 8 only has one number associated with it. So you're looking at your inputs. Each number in the input can only have one output associated with it. They can share the same output, but they can't have two different outputs. So each number has one output. This is a function. This is your reasoning, each input has only one output. Now we can look at part C. We're looking at our inputs. Okay, the 1 has a 9. Now we have two 2's. Okay, the 2 is considered one input, and it has two different outputs associated with it, a 10 and an 11. So because the 2 is the same input with two different outputs, this is not a function. And you would use the same reasoning. There are two different outputs, 10 and 11, associated with x equals 2. Okay, one more example. So now we're looking at graphing. So we're going to graph the function y equals 2x minus 3 with domain 2, 3, 4, and 5. And we're going to make a table and identify the range and then graph it. So this is a discrete graph. Next time we'll talk a little bit more about discrete and continuous graphs and what the differences are in the next couple of lessons. So the first thing we want to do is make a table where you are given a specific set of x's. Okay, I don't want any other x's. I'm only interested in the 2, the 3, the 4, and the 5. Okay, that's one of the reasons this is discrete, because I gave you a specific domain. We are only going to use those 4 points. We are going to plug them into our equation. Y equals 2x minus 3. So the first one, y would be 2 times 2 minus 3. That's 4 minus 3, which is 1. Next one, y equals 2 times 3 minus 3. So where the x is, I'm replacing each of your x values with the variable x. So that's 6 minus 3. So that's 3. So in the first case, the point is 2, 1. The next case, the point is 3, 3. And then you continue with the rest of your points. It says to identify the range. So remember, the range is the set of all y values, your outputs. So it would be 1, 3, 5, 7. Those are your outputs. That's the range. So it's those 4 numbers. And now we're going to set up our graph. So when you set up your graph, you need to make sure that you're labeling your x and y axes appropriately. You're using a ruler to get a nice straight set of axes. Also a nice straight line if we're going to connect the dots. In this case we are not, because it's discrete, and I'll explain that a little more in a minute. So we are going to set up our graph. It does not have to be in the center. Make sure you have arrows on all ends. This is the x-axis. This is a y-axis. Make sure you label them with the x and y variables on the side of your axes. You have to scale your axes appropriately. You must have minimum, middle, and end. So that would be this number here and this number here. So that would be minimum all the way around in the positive and negative directions. I prefer more, so at least every other number. So I'm going to go 2, 4, 6, 8, 10. That is a much nicer and neater set of numbers on your axes. You must also go in the negative direction. -2, -4. Again, minimum, middle, end. But it must go all the way around. So 2, 4, 6, 8. And then going down in the negative direction, -2, -4. Again, you must complete your scale all the way around, however big you make your x and y axis, your coordinate plane. You have to use all the axes, all the numbers all the way around, just like you see here. All right, now we'll plot some points. So we have 2, 1. So you go to the right 2, up 1. It's always the x first, y second. Then we have 3, 3, 4, 5, and 5, 7. Now, like I said before, this is discrete, which means you're going to leave it just as dots. You are not going to connect the dots at this point. Later, we'll talk about the difference between discrete and continuous and when you're going to connect them and when you don't. In this case, I gave you a specific domain. That's the domain we are graphing, so it's just those 4 dots. And that is our graph. So just a quick review. You want to identify whether a relation is a function, so we did that. We'll review some more of this in class. You want to identify what the domain is and what the range is, so we talked about how you would do that. We also talked about graphing a discrete function. So that was the first graph. We'll do a little more of that in the next class, and then eventually in the next couple classes discuss the difference between discrete and continuous, which leads me to the last note. So over the next couple of days, we will work with the same concepts that I have listed. We'll talk about functions, we'll talk about graphing, we'll talk about domain and range. I'll see you in class.